Hello everyone, and today we will be seeing one of the problem from Leetcode. It says minimum absolute difference. The problem is pretty much simple, that we are given an array of distinct integers named ARR, and we need to find all the pair of elements with the minimum absolute difference of any two elements, and we wanted to return a list of these pairs in ascending order, obviously, with respect to pair. So each pair A and B follows AB, A is less than B, and B minus A equals to the minimum absolute difference between the array elements. So we have a bunch of elements over here, and I guess 3, 4, 2, 1, these are the minimum difference elements, but because minimum difference within the array is 1, you cannot find below 1. You can obviously find maximum difference as 3, 4 and 1 with, but minimum is 1. Same with this one, where you have minimum as 2. You can take any other elements, but minimum is 2, and only this pair qualifies with that. Constraints are pretty simple, so how can we deal with this? As this is no brainer, we wanted to go ahead first of all, and you have to find it. Hey, what is the minimum difference within the array? So initially find minimum difference of that array. Once we are once we know that what's minimum difference, take the pairs and understand whether this pair qualifies or not. So with this we can go how we are going to find the minimum difference. One thing is, you can take each of the pair possible, which is O of n square, and then you can proceed that hey, this qualifies, this does not. Else you can go ahead and you can understand that hey, we can sort this list, and once we sort it like this, okay, I wanted to take it below. Cool. So I'm having it as like this, yeah. And once we sort this array A, which is arrays dot sort A, we will get it into a ascending order, and this ascending order is essential for us to understand the minimum difference. Now once we have that minimum difference with us, once we have the sorted array with us, I can just go ahead with I is equal to 1, I is less than a dot length and I plus plus, and for each I'll understand that hey, if the minimum difference int min is equal to a of 1 minus a of 0, we can understand that min is equal to mat.min of min comma a of I minus a of I minus 1. So this is how we can store it, the min. And once we are done with getting the smallest min, we can go ahead and take this we can go ahead and populate each pair within the result array. Now what I wanted is just to understand that hey, if a of I minus a of I minus 1, if it is greater than min, I don't want this, I just want to get continue with next element. Else what I want is else if it is equal to min. Let's do it like this. If this is equal to min, then that means these two items qualifies. And what I'll do here is result.add list of a of I minus 1 and a of I. In this way I'll go forward and I'll return the result. Let's compile this. Okay, this is always the case, right? Yeah, compile this, it is accepted. For sample test cases, let's do it for rest all the test cases as well. Obviously the time complexity has slightly been improved. It is no longer n square, it's n log n. I see we have yet another fast approach. I'm not counting these approaches because these are just IO writers, these are cheater guys. Like this is bluff, man. You don't want it to do this. And there is yet another problem. It's very very dirty. I'm not saying dirty code, but this is not very readable code. What they have done is just like a sorted and n log n. Along with they have went in finding the min, and along with that they have went in +1 array element lookup, whereas we did with -1. Both are fine, and they went ahead in this case. So that's all about it. The time complexity is n log n only here and there, and this was a good problem, a decent problem I would say, from arrays and sorting. So this was all about it, and for more such content click the video on your right, and I will see you in the next one.